Welcome back, students. Today I am presenting you a very good problem based on the zero error of the Vernier scale. And this question I hope will clear all of your doubts regarding to the negative zero error, especially in a Vernier scale. So without wasting time, let's start it and read the statement. So this is Vernier caliper is having one main scale division and which is given equal to the 1 mm. Also it is given that in this Vernier caliper 7 main scale division is equal to 10 Vernier scale division. So from this detail only I can write that one Vernier scale division will be equal to 7 by 10 of main scale division, and one main scale division was given 1 mm, so I can write it is equal to 0.7 mm. So I got the detail of one Vernier scale division. Now it is saying that when nothing is put between the jaws of the zero, when nothing is put between the jaws, the zero of Vernier scale lies left of the zero of the main scale. Means this scale is having a negative zero error. Why? Because if this is the zero of the main scale, okay, 0, 1, 2, suppose these are the markings of main scale, and when you are putting nothing in between the jaws, the Vernier scale 0 is lying like this. 1, 2, like this Vernier scale 0 is lying, and this is the error. Suppose this is E, this is the error. So whenever you will take reading from this Vernier caliper, this Vernier caliper will always give you lesser reading than the actual reading. And by how much amount that reading will be less? That reading will be less by a E amount. So first of all we have to find what is this error, negative zero error, and whatever we find this value we have to write finally into the measurement. Okay, that will give us the true reading. So first of all let us find the zero error. Okay, so for zero error what it is given, fourth division is matching with one of the main scale division. Okay, so as I discussed in the previous problem, that whenever you need to calculate the measurement of Vernier scale especially, you just try to find what is the gap that is filled whenever one of the division is matching. Okay, so let me draw this situation. So suppose this is the main scale 0, this is the main scale 0, main scale 1, okay, this is the main scale 2, this is the main scale 3, and this is the main scale 4. Okay, and okay, so this coordinate is 0 mm, this coordinate is 1 mm, this coordinate is 2 mm, 3 mm, 4 mm, and we have seen that one Vernier scale division is equal to 0.7 mm. So suppose when there was no zero error, then zero of the Vernier scale would have also matched with the zero of the main scale. In that case, how the divisions would have been arranged? So first division would have been here, and this coordinate would have been 0.7 because one Vernier scale division is 0.7. So this would have located at 0.7 coordinate. Where the second division would have located? Second division would have located 1.4. Third division would have located at 2.1, and fourth division would have located at 2.8. I hope it is clear to you. You just have to count the table of 7. Now, if this scale is having positive zero error, although it is given negative zero error, but you understand the both concept. If this scale is having positive zero error, in that case this scale will move to the right. So every division of the Vernier scale will try to match with the right side of the main scale division. Okay, and if this scale is having negative zero error, which is given in the question, then Vernier scale will move to the left, as I have shown you here. So every Vernier scale division, whether this or this, they will try to match with the left side of the main scale division. Left sided main scale division. When it is having positive zero error, they will try to match with right side main scale division, immediate right side main scale division, and when they are having negative zero error, then Vernier scale divisions will try to match with immediate left side main scale division. Also during the measurement, you move the Vernier scale in right side. So during the measurement also, the Vernier scale division try to match with the immediate right side main scale division. So keep this point in mind, this will be very helpful. So here the fourth division is this one, and it is having negative 0, so obviously it is going to shift left, and it is shifting left and it is matching with one of the main scale division. So what is the distance between this and its leftmost main scale division? So leftmost main scale division was located at 2 and this is located at 2.8. That means this fourth division has to move by 0.8 mm, then only it will be able to match with the one of the main scale division. I hope it is clear to you. Okay, so from this argument we can say that here the error value, since it is negative 0 error, so error value will be minus 0.8 mm. It is very simple without using any formula. Now let us come to the measurement portion. Now it is saying that when it is used for measurement, then 0 of the Vernier scale lies just right of the 10 mm mark. This means that we have been given that main scale reading here is equal to 10 mm, that is given to us. Okay, and what it is saying? It is saying that fifth division is now matching. So here we will have the fifth division, and fifth division will be located at 3.5, you know that. And I told you whenever we will take the measurement, so for taking the measurement, in which direction we will move the Vernier scale? Obviously we are going to move it in the right direction. And when the Vernier scale is moving in the right direction, then every division of the Vernier scale will tends to match with the nearest right side main scale division. So here also the fifth Vernier scale division, which is here, it will match with the nearest main scale division only if it is moved by this much distance. And what is this distance? We can easily find this is 4 and this is 3.5. That means obviously this distance is 0.5 mm. So fifth division will match with one of the main scale division only if it is shifted by 0.5 mm. That means what we can say, what is the Vernier scale reading? So Vernier scale reading we have to directly take as 0.5 mm. Okay, so what will be the measurement? So measurement will be equal to main scale reading plus Vernier scale reading minus error, because we have to remove error to get the true value. Okay, from the measured value we remove the error to get the true value. Removing the error means subtracting the error. Okay, so let us substitute all the values. So main scale reading here is 10 mm, so I will write here 10 mm. Vernier scale reading is 0.5 mm, so I will write here 0.5 mm. And error, I have already calculated error. Error was minus 0.8 mm. So this minus sign is from formula, and this minus sign will be of error. So this will be 0.8 mm. So what can I write about measurement? So measurement will be equal to 10 plus 0.5 plus 0.8 mm. Okay, so this will be equal to 10 plus 1.3 and 10 plus 1.3 will be equal to 11.3 mm. So the answer of this question is 11.3 mm. Okay, so I hope the concept of zero error and negative zero error as well as positive zero error is absolutely clear to you. And also you can see that we can solve any question based on the Vernier calipers without using any formula if we have the proper knowledge of by how much amount the Vernier division has to shift. If you got this concept, then even if the question is asked with positive zero error or negative zero error, with any kind of proportion, 7 is equal to 10, 7 MSD, 10 MSD, or 7 MSD is equal to 20 MSD, any kind of variation is given, you can solve it. So I hope you learned something new from this video and you enjoyed watching this video. So if you really enjoyed this video, kindly consider giving a like to this video. Also try to subscribe this channel and share my videos with one of your friends and also give them the benefit. Okay, so all the best and thank you.